Hello everyone, so welcome back to my channel and let's start with today's Leetcode challenge, that is divide intervals into minimum number of groups. Until now we have completed 4 challenges. In case you have missed any, you can watch it on my YouTube channel. I have created a playlist for it. Yeah, so let's just start reading the problem statement. We are given a 2D integer array intervals where intervals of I is left I and right I represent the inclusive interval. Okay, so both are inclusive means, and you have to divide the intervals into one or more groups such that each interval is in exactly one group and no two intervals that are in the same group intersect each other. Now we have to return the minimum number of groups we have to make. Okay, and two intervals intersect if there is at least one common number between them. For example, if 1 and 5 are 8, so they will intersect since 5 is common to both of them, right? And similarly, if you can see this example, 5, 10, 6, 8, 1, 5, 2, 3, 1, 10. So we can group 1, 5 and 6, 8 in one group, and similarly 2, 3 and 5, 10 can be grouped in one group, and 1, 10 will be separate because it is like intersecting with both the groups. So yeah, so let's just move to the intuition part to better understand it. Let's just start the intuition part. So we have this intervals array, right? We have this intervals array and a small diagrammatic explanation. So what we have now, we know that first interval was this 5, 10. Now we have this 6, 8 and then 1, 5. So it is 1, 5 and 2, 3. There is a 2, 3 and 1, 10. So now if you see maximum, that at any point if you see intersection, so at this point if you see the number of intersection, then at this point, then at this point, for every point we will check. So at this point maximum intersection is 2. At this point maximum intersections are 3. Similarly here, now if you see here, again 3, again 3, again at this point this is 3, and now at this point 2. So if you see maximum is 3, that is how we will check. So what you will do first, because whenever an interval comes, what we have to do, so we have this 5, 10. Now 6, 8 comes. So what you are checking, if in this time interval is this 6, 8 is coming or not, because if the 6 is coming after 10, then we surely can be placed in the same group, because the condition is that two intervals can be placed in same group if they are not intersecting, right? So that is the main thing that we have to do. So if you see this 5, 10 is here, 5, 10 is here. Now when 6, 8 comes, it is coming in between this. So 6, 8 cannot be placed in 5, 10. So it should be assigned some other group. So what you will do, let's just have this with different pen. So you have this group, let's just say you are assigning 5, 10 to it. Now when 6, 8 comes, it is coming in the same group, right? The same group. Now what you will do, you will create another group with 6 and 8. Now when 1, 5 comes, so what you will check, this 1, 5 is coming in any group, right? So you have to check for this, you have to check for this. When you check for this 1, 5, yes, because 5 and 5 are intersecting, so you cannot place it here. Now you will check here if the end time and the start time, if they are intersecting, so 1, 5 can be placed here, right? Similarly when 2, 3 comes, so what you will check, 2, 3 can be placed here, yes, because when 2 3 and 6 5 10 there is no intersection. Yes, so 2 3 can be placed here. When 110 comes, it will check if it can be placed in this, if it can be placed in this. So 110 is intersecting in 231 also and 151 also, so it will surely create another group with 110. Now if you see, minimum number of groups are 3, so you got your answer. Now how to start, like, approach for this? So basically you are playing with the new event that is coming. You have to check the previous end time and the current start time, right? So every time whenever you take a interval, you are checking if the current start time is in the range of this end time of previous one, right? So you know that whenever this comes, this happens, you have to either take action for this. That means that you need somehow sorting thing, because these intervals, if they are sorted, then only you can check if they are forming a your answer. Okay, so when you see this, okay, so when you see this, you just need to play with end time of this and end time of this and start time of this. So every time you have to play with the current start time and the earlier end time. That's why if you see that when you were doing this dry run, you have to check basically the end time and start time. So you need somewhere first sorting thing, because that will help you build your answer. You see that if give you like this example, 5 10, then 2 3, then 1 6. Okay, when this will come, you will assign it one group. Okay, 5 10. Now you come 2 3. So what do you have to check? You have to check with 2 coming is like in this 10, right? So 2 is smaller than this, but then again you have to check for this 5. So this will not help you build your answer. So if you have somewhere sorting kind of thing, that will give you like this 1 6, then 2 3, and then 5 10. Now if you will try forming your answer, you will have 1 6, so you will create a group with 1 6. Now what comes? 2 3, you will check if 2 is greater than this, no, so you will create another group with 2 comma 3. Now 5 comes, so what you will check? If 5 is greater than this, no, so it is in the intersecting part, so you cannot add it here. Now you will check for this, yes, they are not intersecting, you can add it here. But in this case, when they are not sorted, how you can check? You cannot directly check if 2 3 can be placed in this. Okay, similarly when 1 6 comes, you cannot directly check if it is in the this range. So first thing, you need sorting, right? So the first step was sorting. Now what comes? How you will build your answer? So we will take this example again, right here. And now what we'll do, we will check how we will build our answer. First we will resolve this. After sorting, how it will look like? It will be 1 5, right? Then 1 10, then 2 3, 5 10, and 6 8. This will be based on arrival time. So on arrival time, these are all sorted. So we have this sorted array. Now we know that we just have to play with, we need n times every time for playing with end and the current start. So let's just, every time you cannot go back and check for each every time end time. So you will store it in some data structure, right? We will know what we'll use. So first, when you come to here, you will assign one group 1 comma 5, and you will store the end time. Now 110 comes, so what you have to check, if 1 is this the end time that you are storing, if it is in the range, no, so you will assign another group, okay, and you will store the end time now for this. Now when 2 3 comes, what you have to check, if 2 is in a range of any of the end time, yes, uh, yes or no, no, so because 2 is not in this range, 2 is not in this range, okay, that means that 2 cannot come in this group or 2 cannot come in this group. So what you have to do, you will have to create another group where 2 3 and 3 will be stored here. Now comes the main part, that is the main game. So 5 10 is coming, we have to check if 5 is can come in any of the group with these end times, right? So 5 is coming, yes, so first we have got this, so 3, yes, it can come in this, so we will remove it because we already have this group and this group end time is now 10, so we will add 10 here, right? Now we come to here, because this group is this, now the group end time is this, and if there is any person that is any interval that is coming, if it is in the intersecting in any of them, they cannot come in this. So what are you storing, the maximum of this is 10, the end time, so you store this end time now. Now 6 8 comes, now what you will check, if 6 is greater than, is in the range, no, but you see that it can come into this 1 5. So how you can get this, if this storage is sorted, okay, that means 5 10 10, now you will automatically get this 5, and 6 is greater than 5, that means that you can store it in this 1 5, and 6 8 can be added, now 8 will be added here, and when at the end you have this storage whose size is your number of groups, because if you see the end time of this is 8, maximum time we already have, this end time we already have, this end time we already have, so you know this, you have your storage, so storage size was your answer, right? Now if you see that when we were building the solution, this was a dynamic storage that we are using, dynamic, right, dynamic storage, and we want the storage to be sorted, so dynamic plus sorted, but what you have to do, you have to use priority queue, can use priority queue, so you have to, so what you can use priority queue, because this is a dynamic storage which can give you sorted form. If you use mini, on mini will give you non-decreasing, and max will give you decreasing, right? So whatever you want to use, you can use it, but if you see here what we'll need, we need smallest at the first, so we'll use mini, right? So I think we have got our solution, right? So we will just do a small dry run over the other example that we have. Okay, now if you see we have this intervals array, so I will name it I, you have it 1 4, okay, now 2 3, now 5 8, now 6 7, and 9 10, right? So we have this, we will check what will be our answer. So first if you try to group them 1 and 4, 1 and 1 to 4, right? So now 2 3 is in this range, so 2 3 will be assigned, another 5 8, 5 it can come here, here also. We can assign it to any of them. We will assign it to here 5 8, 6 7. 6 7 cannot come here, it can come here 6 7. Now 9 10, 9 10 can come any of them, so 9 10 can be added here. Okay, so only two groups are needed, right? So we have got our answer as 2. So now we will do our approach that we discussed above. So this is sorted, okay, by their start time. So we don't have to do sorting now here. Now what we'll do, we will come to this. Now we have our start time, end time. If you see, you don't have any group now, so what you will do, you will have one group. So this is a like uh, memorized group. I'm not creating any storage for this. So you will have this group, and what you will have to add, end time here. Now you come to this, what you will have to check, start time with the end time you currently have. No, it is not, because it is in the range of this 4. So what you will do, you will create another group with 2 3, and this value will be added. Since this is already coming sorted, we don't have to sort it. Now you come to here, right? 5 8 is coming. If you see 3, 5 is already greater than 3. So what you will do, you will add this here, right? 5 is 8, and now you will remove it because this group is currently 8. So you will remove this whenever it is in the range, remove, then add 8. Now currently this is not sorted, so you will basically sort it 4 and 8. Now you come to here 6 7. You will check 6 is greater than 4, yes, so you will add this here. Now 4 will be removed and 7 will be added, because 7 is the end time, you added. Now it is already sorted, you don't have to sort it now. Now you come here, 9 is coming. 9 is greater than this, yes, so you will remove it and it will be added in this. Now the end time is 10, so you have added 10 here. Now whenever you come out it, so you have already processed all of them and your size is 2, and this is your 2, and we already have our answer 2. So I think we are good on the approach. Now what is the time complexity? We will discuss it while writing, and the space complexity, okay, that will give us better intuition. Now we will move to the coding part to understand this approach more better, right? So we have this, what we now have to do, we will have one size variable, so intervals dot size, right? We have discussed that we have to sort it, so we will sort it, intervals dot begin and intervals dot end, right? We have sorted it. Now what we have to do, we will start from first till last. Now we will store our int arrival time, that is intervals I 0, and int go departure time, right? So we can name it, right, that is a good convention, and this is 1. Now what you have to check, this will be, we can name it end time, and this is start time, so better it. Now what you have to check, we have forgotten to make our priority queue that will store our end times. So priority queue will be of mean heap type, so it will be vector of int and greater int. This will store our end time, so end time storage, okay, this is min heap, right? So now what you have to check, if your end time storage is empty, if it is empty, That means that there's no currently anything in this. You just have to add end time storage dot push. What is you have to push this, right? If it is not empty, then what you have to do, you have to check, right? What you have to check now, if end time storage, right? End time storage dot top, what you will get, you will get the minimum time. End time storage dot top, what it should be, it should be smaller than your current start time. If it is yes, then you can add the current interval into that, basically that group. Okay, now what you have to do, you have to pop this, remove this, because you have to update it with the coming end time. So you will pop it, and again what you have to do, you have to again insert it, right? So you have gotten your answer. Whenever you come out of this, you just have to return your end time storage dot size, right? So I think we are good on this. And one improvisation that what we can do, we can club it this uh, in one operation directly. So we'll do it later. Let's just try run it. So we are getting a wrong answer. Why? Okay, we have sorted the array. We are having a priority queue. Start time, end time is this 01. Now what you have to check, you can directly push end time here. End time, yeah. So what is this missing that? Okay, so whenever this will be empty, we are adding, and whenever this will not be empty, it will come to here. And if this condition fails, we are not doing anything. Then what we have to do, we have to add our end time, because it will create a new group, right? That comes when we are handling this 2 3 case. Okay, so end time we have to push, right? Think now we are good. Yes, so let's just try to submit it. Yes, so we have submitted it successfully. Now the improvisation that we can do, right? So we were discussing that little improvement that we can do. So what we can do, we will add this check with this empty check, and we can do this thing, right? And what we have to do, we will add this check, do it, this operation here, and all this can be done after this if, because we are doing the same thing, right? Now if you see, we are doing the same thing. Whenever our end storage is empty, end time storage is empty, so we will not come to this if, we will surely add this end time. Now if this is not empty, then you have to check if it is like in the start time is less greater than the end time storage dot top, that is the end time that you earlier have. Okay, if it is also not true, then it will come to here again. Every time you have to do this. So we are doing this now, and we are removing this. So let's just try to submit it. So what is, okay, so mistake, time dot push, right? Yeah, so we have done this successfully. And now the time complexity thing that we were discussing. So it is like, since we are sorting, so this is n log n, right? So this is n log n. Now, if you see, this is running for big of n time. So this is big of n, and every operation on priority queue is of log n time. Okay, so log n time. So if you see n cross log n, so again it will be, so the total time complexity will be big of n star log n plus big of n star log n, right? So this is the total time complexity. If you see space, so we are using this uh, priority queue. So the space complexity is basically big of n. If any time it will store maximum of all the intervals, right? If all of them are intersecting, right? Yeah. So a little improvisation on this time complexity part. We can do one algorithm that we know, that many of us know, is sweeping algorithm. So let's just move to our intuition building part. I will give you a short glimpse for that, and you can try it on your own. So if you see that, what you have your intervals like this: 1 5 2 6 3 8 4 10. Okay, and let's just create a small number line type thing. You have your 1, so this is 1, right? Now 5, so till 5, this is 5, so till 5 you are blocked. So let's just say you mark it somewhere this as this, and till 5 you are all blocked. So what we'll do, we will mark 6 with somewhere like a dash. That means that from here you will be available again. Now again when 2 6 come, so you will mark 2 with dash, right? And 6, so this is 6, so you will mark 7 with dash. That means from 7 you are free for this interval. Now when 3 8 comes, so you will mark with 3 with this, and 8, so this is 8, so this is 9, so 8 plus 1 is 9, so you will mark this position because until this you are blocked. Again when 4 10 comes, so this is 4, you will mark this with this 4 basically area, and now 10, so you will mark 11 with dash, right? So what you can do this in the sweeping algorithm. Now if you see, I will build a small uh, graph type thing, some matrix thing. So 0 1 2 3 4, maximum is 10. So what we'll do, we will do from 1. Okay, we are starting from 1. So this is 1, this is 2, this is 3, this is 4 5 6 7 10 11. Similarly, so what we'll do, what first is 1 5. So when 1 5 comes, you will mark 1 with 1. Now 5 is here, so 6, at 6 you have to mark some dash. So what I will do, I will mark 6 with -1. That means from 1 till 5 all are blocked, and from 6 it will be unblocked, right? And currently all are 0 0. Okay, now when 2 6 come, right? 2 6 comes, what you will do, you will mark this with 1, and 6 with 6 was this, so -1 with 7. When 3 8 comes, if you see, 3 is here, and 8. So you will mark 9 minus 9 with this. Now when 4 10 comes, 4 is here, 10 is here. So you will mark 11 with minus 1. Okay. Now if you see the logic and the ideation behind this, at this point 1, you see only 1, right, for every of this column. So you will just write it. So this means that from at 1 you only have maximum of one room, one group that we say. Now when you 2 comes, what do you see? That it is like it is coming in this 1 starting. So at max, when you see the diagram, that if you draw it like this, let's just say you have your diagram, a small diagram like this, 1 5. So 5 was here, let's just say 1 5, right? Now 2 6. So 2 is starting from this, 2 6, then 3 8, then 4 10. Okay, all of them are intersecting at this 1, at this 2, at this 3, and at 5. If you see, 4 are intersecting. Okay, but at 4 only 3 are intersecting, right? From this diagram, if you see. Now for 6, if you see, 3 are intersecting. For 8, 2, and at 10 only 1. So from this diagram you will understand. So for 2 it is 1, right? And in the 3, if you see, only 1, and for 4 you will see only 1, but 1 is coming from beyond. So what you will do, you will we will do it that operation later. So for 5, if you see, 0, no one is there. For 6 you will see -1. For 7 you will see -1. For 8, 0, then -1, then here -1. Okay, this is also 0. Now 1 is here. At this point, if you see, from before, what is coming? 1. So at max, if you do it like this, will be updated to 2. Now if you do this, 2 is earlier and 1 is in same, so this is will become 3. So we are doing this prefix sum, right? Now 3 is here, 1 is here, so you will update it to 4. Now it is 0, you will not update it, because currently it seems that for 5, if you see, for this 5, if you see, how many of are intersecting? 4 are intersecting. So you have your answer, I think. Now -1 comes, so that means 4 minus 1, that is 3. So if you see at 6, maximum of 3 are intersecting. Okay, now this -1 comes, so at this point it will become 2. If you see now, at this -1 is at 7, so now you see 2 6, this 3 and 8, so this is somewhere this 7. And if you see at this point, how many of are intersecting? 2, right? And if you see at 7, this is 2. Now again at 8 it is 2. Now when 9 comes, it is becoming 1, because after 8 9 somewhere here, and at 9 only one of them are is intersecting. And at 11 you have your 0, right? So because 10, at 10 you have 1, and after 10 you will have 0, so at 10 you will have 1, right? So this is somewhere giving your answer. And if during this you can check if maximum of numbers you can, what you can have, this 4, so 4 was your answer. And if you can directly see, since all of them are intersecting, this cannot be placed here, this cannot be placed in any of them, similarly this cannot be, So you will have your maximum answer as 4. And if you will try to build this on any of your example, it will surely give that correct answer, right? And so you can also try to dry run it on your above examples that we have discussed, and that this improvement is basically what it will give: better time complexity, because time complexity will be in this case big of n, since we are not sorting any this thing, right? We will not sort because we are just using this start and end and directly marking in one of our array. We will take one array of size that is maximum that we have given, and we will update this 1 minus 1 in that array, and we will build a prefix sum, and during that our answer. So this will be a big of n approach only, and space complexity will be big of n only, or because we will be using maximum size, so it will be like the maximum n can be in the range, so that gives n only. So thanks everyone for watching. In case you do like this video, please do hit that subscribe button, and in case you have any questions, please do ask in the comment section. I will try to answer all of them. And if you have any doubts, queries, you can directly ask me on my Instagram channel, and